Today's lesson is on nuclear chemistry. So, what is radioactivity? Well, all atoms are made out of all substances are made out of atoms. They have electrons that circle the nucleus. Your nucleus is in the middle, and in your nucleus you have protons and neutrons, and your nucleus is very small. Radioactivity is what results from an unstable nucleus, and it's going to decay into a more stable nucleus. And it's completely spontaneous. The energy that's released is called radiation. Okay, so the first type of radiation we're going to learn about is alpha particles. So an alpha particle is 2 protons, 1, 2, and 2 neutrons. It has a charge of +2 and a mass of 4. These are slow and heavy. They can travel about 10 centimeters, and that's it. They have a very low penetrating power. They can be stopped by paper, and they're used in smoke detectors. Okay, so you can see here that we have a uranium nucleus that has a mass of 238 and 92 protons, and it gives away 2 protons and 2 neutrons, so it's a mass of 4, and it's changed completely into this thorium atom. And the mass is down by 4, and the atomic number is down by 2. Okay. So it loses 2 protons, it changes into something else. It changes into a completely different element. So uranium has changed into thorium. So let's do a little bit of practice with this. So if we are giving off this alpha particle, and this is what it looks like, 4,2 helium, okay, we know that this is right because 226 plus 4 gives us 230. 88 plus 2 gives us 90. And if we look at our periodic table, thorium is at 90. Okay, for the next one, we're going through alpha decay. So my top number is going to decrease by 4, so it's going to become 205. And my bottom number is going to decrease by 2, so that's going to become 81. We look at our periodic table at 81, and we see that it's thallium. Okay. For the next one, we have alpha decay happening again, 4,2 helium. So the top number is going to decrease by 4, so from 234 to 230. The bottom number is going to decrease by 2. So we look at our periodic table. 90 is thorium. This one doesn't give me much information at all, but I can fill it in. I've got 4,2 He. So we're going back to the original. So I have to add 4 on the top, so it would be 242 over 95. And we look at 95 on the periodic table, and we get americium. Okay. The next type of decay we're going to talk about is beta decay. So during beta decay, a neutron is converted into a proton and an electron. So let's take a look at what happens. Okay, we have the mass does not change, okay, but the number of protons increases by 1. And so we can kind of see here that 7 plus a -1 gives us 6. And so this is what a beta particle looks like. Okay, so beta particles is essentially an electron. They have a charge of -1, and they're basically weightless. They're fast and light. They have a medium penetrating power, so they can be stopped by something like a sheet of aluminum foil. And they can travel approximately 4 meters. So let's practice with this. So remember, for beta decay, we're moving up once beta decay happens. So we have 91 here, so this is going to be 90. The number on the top isn't going to change. It's 230. And then the atom at 91 is proactinium, Pa. The next problem here, we are already given that we have beta decay, we have our bottom number. All we need to show is that this is 209 because it's staying the same. Okay, neptunium going through beta decay, top number is going to stay the same, 238. Bottom number is going to go up 1 to 94. And on the periodic table, that is plutonium. And we're going to draw our beta particle, 0, -1, E. The next type of radiation we're going to talk about is gamma. So gamma is not a particle. It's basically just energy given off. And I like to think about it as you have this large, unstable nucleus, and the only thing that really needs to happen in the nucleus for it to get stable is for it to rearrange itself. So once it rearranges itself, it becomes more stable. And because it's more stable, it gives off this energy as kind of like a phew, like I did it, I made it happen. And it's just represented by a 0, 0 gamma. So let me show you how to draw this. 0, 0, funny looking Y thing. Okay, now gamma radiation has the highest penetrating power. It takes a thick sheet of metal like lead or concrete to block it. So this is why when you get like an X-ray, they put you in a lead apron, or they have a piece of lead covering other areas of your body so that those areas of your body aren't exposed to the radiation. And the person who does your X-ray usually goes behind a concrete wall to do the X-ray. Now, an individual X-ray is not very damaging, but if you're an X-ray technician, you're doing probably hundreds of X-rays a day, so they need to protect themselves. Gamma waves can travel really far. So they can travel hundreds of meters. So usually, obviously, the rooms that X-ray machines are in, they're going to be in concrete rooms. These are used for like diagnostic imaging, so X-rays, CAT scans, etc. Cancer therapy, this is the kind of radiation when people say they're doing radiation for cancer. And it's used for sterilizing, you could use it for sterilizing instruments. You can also use it for sterilizing food. Some food is gamma irradiated to kill germs to make it last longer. So this is just a visualization of the 3 different types of particles, or 3 different types of radiation, and what can stop them. And here we have just a summary slide. So it's got the type of decay, the equations, a representation, a picture of it, and what happens to the mass and the atomic number.